I'd like to show you the difference between a DC, AC, and transient simulations on a high-pass filter. Here we've set it up with a 1 volt DC source, 1 microfarad capacitor, and 1 kilo ohm resistor. And it's all set up for a DC simulation. And we'll press run. Pops out. V1 is 1 volt. And there is a current 1 times 10 to the minus 18 amps. And the reason why there is a finite current like that is that SPICE connects small conductances, very small conductances, between every component for convergence issues. But these numbers are effectively 0. Now let's simulate the filter response AC. So we will right click on the voltage source and go to advanced, and we will enter in an AC amplitude of 1 volt. And now it says AC1. That's how we can tell. Now we'll change the simulation to AC. We'll sweep it by a decade. I like to use 10 points per decade, start at 1 hertz, and we can stop at 1 megahertz. And I'll place that down here. Press run again, and up pops a plot with logarithmic frequency projection, and I can plot V1 and V2, and we can see that V1 in blue, which is the input, is 0 dB, which is 20 times the log of 1 is 0 dB, and we can see the filter response is certainly a high pass. And if we start at 0 dB and come down 3 dB, we can see that the cutoff frequency is 156 hertz. Now we can go back and set up a simulation for a transient, and we can do the step response. And we can start off at 0 volts, step up to 1, a delay of 0 seconds, and we can program the rise time to equal 100 into tau. We can do T fall as tau divided by 100, and we can do our T on, the pulse width, as 5 times tau, and the period as 10 times tau. And we can press F8, stretch this out so we can see. So tau is 1 millisecond, rise time tau divided by 100, fall time tau divided by 100, pulse width 5 tau, period 10 tau, and we'll run our simulation for 2 cycles. So when we go simulate, edit simulation command, I can put in the variable stop and place that down. It comments out the other simulations. Run. And I got an error. There is something missing. I have RT, FT, RT, and that should be FT. Now it should run, and there we go. The step response of a high-pass filter, where we know that it starts off at 0 and has to end at 0. How does the voltage of V2 come up? Well, that spike, or the rise, Laplace transform is 1 over s, so there's a lot of frequency there. The derivative of that, the current in a capacitor, is the derivative of the voltage, which is certainly high, brings the voltage up, and then it decays.